We have the following circuit to the left. To the right, we have an NPN and a PNP BJTs. And so I've just included this just to show which one this is. Now, when we look at this, it's going to be a PNP, and that's because the arrow points into the base. For NPNs, the arrow on the emitter, which is right here, points out of the BJT. And a tip to remember this is that NPN means not pointing in. And for PNPs, the arrow on the emitter points into. So we always look at the emitter. If it's NPN, it's pointing away from the base towards the emitter. If it's PNP, it's pointing away from the emitter towards the base. And if you ever forget that, you can just come back to this video or look in the notes linked below the like button to find this information out. But now we're going to solve this problem here. So for the BJT bias circuit shown, what is the emitter voltage VE in volts? So we need to use VCC as 8 volts. So we can write these down. VCC is equal to 8. Our VEE is equal to -7. Our VB is equal to a -1.9. Your values might differ, but the process, once you get all of this down, is going to still be the same. Our RC is 1.7 kilo ohms. Our RE is going to be 9.6 kilo ohms. We can assume the transistor is in a forward active region. We have our beta here and our VBE on, which is 0.7. And VBE on is our voltage base emitter, and that would be somewhere like we would say right here, VBE. Now, when we look at this, it's super simple. All we need to do is look at this node to find what we're looking for. Because remember, we're looking for our VE, the voltage of the emitter voltage. So we're going to look right here because we want to find this, right? So we're going to say, well, we know we have some voltage, VB, going out this way, right? Because of the arrow of the current. So we're going to have our VB. And we know we have some voltage going out this way, right? We have voltage splitting across both of these ways. So we have VB plus the other value. And this other value is simply going to be our VC. And then not our VC. This is an important thing to note. So our VC is right here. However, our VBE is right here. VBE comes before it. So we're actually going to be looking at our VBE. So we have these two. And well, what about the voltage going into it? Well, that's going to happen to be our VE. So this is equal to our VE. And that's how we would look at this. If you want the, I think it's the node voltage method, where we're looking at the voltage into the node, the exact actual equation for this would be VB plus VBE minus VE is equal to 0, because the voltages going out of our node are positive and the voltages coming in are negative. So that's how we would write this. Now, all we need to do from here is plug in our values. It's that simple. We were given our VB. Our VB is -1.9 volts for this problem. Our VBE is the VBE on, which is 0.7 volts for this problem, and this is equal to the voltage on our emitter. So the voltage on our emitter is just going to be -1.2, and this is going to be measured in volts. So that is how we find the voltage of our emitter. If we wanted to find anything else, there are videos about that linked below the like button in the playlist. It's the previous section before these videos.